So this session, um, building on inventory management to look at inventory control techniques. So when we're talking about inventory control, basically we are looking at how to ensure that we have inventory in store that can be able to help us achieve certain objectives, especially customer satisfaction. Every organization has its objectives, and the thrust of these objectives is customer satisfaction. How do we make sure we provide goods and services to satisfy humans or our customers? And there are things that we need to do to ensure that we have adequate stock at a good price. You see, sometimes if you don't have certain supplies, you will be forced to go for expensive ones because you need them, right? So it's always good to make sure you have supplies in stock. Otherwise, you will be forced to. Sometimes remember, if you need something and you don't have it at home, assuming you are cooking and then all of a sudden your gas uh, runs out, you run out of gas. What does it mean? You may be tempted to go for a chartered taxi or anything because the food is half cooked, So you have to run and go and get some. And that will be expensive. If you were to take your time and go and fill the gas, you may have gone with the shared bus or other means of transport that are cheaper. But this one, you need express transport system. So you see that you can actually have issues with your production and operation system and customer satisfaction when you don't have adequate inventory of the things that you need. Imagine even if you have to go and fill the gas and come, by the time you come, your rice or whatever food it is on the farm may have lost its value or something will happen to it. I mean, it may not be perfectly as you have it, or maybe you may have to go and beg your neighbor, and all those time that you are waiting, food sciences will tell you cooking must have constant heat for most of the things that we cook. So you see that there can be problems. So the things that we need to do is to make sure we have periodic inventory review. How do you ensure that your stocks, you check the level of your stocks regularly, basically. And you need to have review systems that are there almost all the time called the perpetual inventory review systems. You have to make sure you have safety stock. So the last time I had issue with
Yeah.
gas cylinder drying out in the middle of cooking. So I have decided that I will have to get a standby gas cylinder. So now I have two. You are a student now, so you may not have the luxury of buying two cylinders. Yeah, but if you have a roommate, then you both have cylinders. You can share one, and then one will be a safe buffer, a safety stock. So don't fill only one and keep. If you have more cylinders, just fill multiple and keep just in case. But I mean, in real life, you see people are even having multiple cars. People who rely on their cars 24/7 for business and other things, cars will definitely break down. And so they would like to have buffer. Yeah, you don't want to wake up and preparing tea before you realize, I don't have milk, or I don't have this, I don't have that. You see, so you want to keep a couple of things as buffer. So that is basically what we call safety stock. You need to ensure a stock level that you are not going to run out of stock in a twinkling of an eye. Then we also have what we call just-in-time systems, which you are familiar with, where we don't normally keep stock. Stocks may come and leave, or may not be kept in the store or warehouse for too long, or basically almost arriving and leaving the same time. Yeah. And then we have vendor management inventory, um, where your vendors are the ones who take charge of the inventory to ensure anytime there is uh, stocks, anytime stocks are low, the vendor would automatically be alerted, and then the person will replenish. You don't have to always be going with supply mode. They are connected to your inventory or your warehouse. So they are aware, they are giving information real time. So these are some of the ways we can be able to ensure that we have adequate inventory controls in place. So the periodic review system, which we discussed earlier, it calls for regular examination of your inventory from time to time. Whenever it is necessary to order a replenishment, then you order what we call reordering. Okay. So the size of the order will depend on your predetermined reorder quantities. So that's why we're going to look at economic order quantity, because we always need to be sure that we are not ordering too much and we're not ordering too little, to ensure that we enjoy the best cost benefits in the process. So you have certain inventory levels. Let's say inventory level where we have Q is equal to 17 when you order 17 quantities. All right. So if assuming you have only 3, you can order how do you call it? 17 more. So the Q there is your reorder quantity. So if your inventory level is 3, you can order 17. When you add to it, it will become what? 20. Maybe you want to keep maximum stock level of 20. If your inventory level is 9, you could order 11. Then it adds up to 20. If you don't have any at all, you have to order all the 20. So these are the some of the calculations or considerations. It's an illustration, so we'll be looking at the detail, but yeah, it's just to tell you how to set stock level and how much to buy at what time. The perpetual inventory system is where we continuously track our inventory on daily, maybe sometime per second. So you go to some supermarket or stores, you see that when you are buying anything, they are scanning it with the barcode scanner. Okay, so once it is scanned, you hear ping ping. Once it's scanned, it reduces the quantity of inventory we have in stock automatically. So there's a store keeper or inventory manager somewhere who is checking. Once somebody buys, it reduces the quantity. So if assuming it was 500, today maybe about 60 is gone, 100 is gone, it will automatically reduce it. So store managers can have real-time notification about the levels of stock, and some software actually provide for alarm systems or notification system where they tell you, okay, your stock you have only 20% of this particular item left in stock, so you need to order. So then you can place the order. So there is this sometimes automated systems. Now AI is helping to automate so many things and provide ideas about how we go about it. So we also have what we call the vendor managed inventory, which I explained earlier, talking about the fact that our vendors can have access to our stock inventory data, and then they can now be able to replenish it immediately. The stock runs out without you even coming in. You'll be there and say, we have brought you 1 truck load of this. How do you know? Because they know that this one is done. Normally there'll be some communication anyway, but you don't need to always have to order. They can alert you. Okay, it's just like when you are making calls, right? They will tell you you have 1 minute remaining, that kind of thing. Okay, so the telcos have an inbuilt system, AI system, that tells you already that your credit levels are low. Okay, but most of the time we don't have the vendor managed system where they automatically upload. Some people have what we call the postpaid, where they can make calls as much as, and then they will just get billed later. So this is a sample, but in real life, it works for many businesses that deal with product that can easily be replenished without placing the order. It's like similar or almost the same thing over and over and over. So you don't need to order different types unless there's a new brand or new variety that comes. Then they can let, we have this one. We can give you more variety. Then those discussions can take place. So with the vendor management systems, it's also in some cases inventory may not sell as an organization. If your inventory is not selling, you can also purchase, or they can come and purchase or call it back. For example, if they realize that now this particular product is not selling, it's been here for 2 months and it's not going, they can actually say, okay, this one is not selling. They can come for it and take it back and go and give it to other customers. Maybe your geographical location, they are not buying that product again or something. They can give it to other people where it is needed. So it is an efficient way of managing stock. So you will just sit back and your vendors or your suppliers will check to see which stock to replenish, which one to come and take back, and which one to distribute to other centers. So it helps really make inventory management very, very useful, or let's call it stress-free, or maybe more efficient. Yeah, from the perspective of the customer. Then we have just in time, which you are quite familiar with, that we try not to keep inventory at all, or in cases that we have to keep inventory, they must come and go almost immediately. Okay, sometime maybe a day or two, then so we are not buying too much, so we don't keep too much inventory stocks. But this happens only when we are able to provide some assurances for deliveries on time. If your supplier cannot supply on time, then you may need to keep stock. But if your supplier, for example, comes around every day in trucks, then you can at most keep stock for maybe 2 days or 3 days. So you don't need to keep for 1 month, 2 months, 3 months. Okay, so that gives you room not to tie up your capital in stock, because suppliers will supply you within days. Yeah, either within days or even hours if you are receiving your supply. So let's look at Blue Skies Ghana. It's a fresh food processing company. So they process fresh fruits, pineapples, mangoes, nuts, and others for export to European and local markets. So they actually operate as a free zone. I know they export a lot abroad and a few in the domestic market. The company operates in an industry where freshness is critical, making just-in-time essential. So they have to produce not 10 million tons and keep it for 5 years, 3 years. Like, it's a fresh food use, so they have to actually look at uh, uh, just-in-time kind of thing. Not that it's produced and consumed immediately the same minute or second, but the time to reach market should be short. And that's why we call farm to factory coordination, to ensure that product or even the fruits that they get from the markets or from their suppliers must also arrive on time. No fruits don't keep long and they are gone. So you need to get them early. And when the juice are also, or the smoothies are prepared, they also have to go to the market on time. So there must be that kind of coordination to ensure that products or supplies come in daily and go out daily, and as soon as we need all their produce. So there's also a real-time demand tracking where they check the markets to be sure which markets work. Okay, German market or the French market, they must always check to see where the products are needed. And that is why they have to hold minimum stock or minimal stock. You see, so you can't keep thousands of tons of fruits. Where are you going to keep them? It means you have to operate a very large cold store system, even that some will still go bad. So they have to find a way of converting materials or input into process or finished goods within the shortest possible time. Yeah, so the advantages of this kind of system is that it eliminates cost of storage. You spend less money on storing the raw materials, and also cooling, security, insurance, and all those things that you will need when you are keeping a lot of material. But the disadvantages are simple. One is when the supply system or the supply chain is not reliable, you may need items and they are not coming, and then your supply will delay. Your customers will not be satisfied because they don't have product, and then people may switch to your competitors' product if you don't supply within a reasonable time. Yeah. So let's look at stock keeping or stock inventory management, yeah, using the SKU system. So it is very important to understand that our stores also need a system where we have input, storage system, and output track at almost real time. So the SKU system is um, a system that is used uniquely for description, for identification, and or coding or for identification and tracking of inventory. So it helps us to easily, right, receive or maybe identify what we need to replenish our stock with, how to receive it, and then how to store it. So automobile industry, car manufacturers, and other auto parts um, may have so much. You see, when you look at the car, you see it's made up of so many parts. Okay, and those parts you may find difficult to remember all of them or to identify them with just looking at them. So the system here, the SKU system, help us to work with some of those complex. If it's just maybe rice and sugar you are buying, you may go for simple systems. Yeah, even manual systems can still be helpful. But where they are a bit complicated, need more automated systems to help you achieve that. So the SKU systems are normally made up of scannable barcodes that are printed on products. I'm sure you have seen barcodes before. Uh, they are on products, and inventory management software will generate the codes for the SKU, and then the barcodes are printed and uh, placed on every items that is received. So once the items come to the store, they attach the barcode so that in the end, when they are being sold or issued to production, they will scan it again. So it came in and left. So it's like signing in to an office and signing out now. I'm sure you have been to certain offices before. When you are entering, you have to sign in, and when you are leaving, you have to sign out. And that is basically the system here where barcodes are designed and embossed on the product when they are being received. And then the same barcode will be scanned to show that this particular product is going out at the end of the day. So that is basically that's how it works. So you see, barcodes for similar products can vary. Maybe even Coca-Cola, the sizes, right? So they may have different sizes. Among the soda drinks, Coca-Cola, Fanta, Sprite, Mirinda, 7-Up, Pepsi, and all that. Each category of or brand will have different barcodes coding system, but every category, all the products in the same category would have similar or same barcodes so that for pricing and identification purposes, we know that this one, once you scan, this is Coca-Cola, 250 ml or 300 ml, what we popularly call the Akufo-Addo size, or this is a plantain chips, okay, maybe half a kilogram or something, so that they can all have similar identities for pricing purposes. All right. So let's look at we look at these systems and how we can be able to ensure that we keep inventory. And now let's look at one of the important concepts we've been talking about, the EOQ, okay, in more details. So EOQ, as we discussed earlier, is a model of fundamental inventory management tool that we use to determine exactly how much or how many product or how much of the quantity in terms of quantity, okay, should we order at a particular time? So you may set your stock level, this is the reorder level, but at reorder level, how much do you need to buy? If your gas is exhausted in your cylinder, how much are you going to refill? Basically, that's the idea. Okay. If you are, if you want to cook food and eat because you are hungry, how much food should you buy? How much will satisfy you? That is a system we are trying to discuss when we talk about EOQ. So the EOQ determination is very important. Why? Because we want to cut down costs. We don't want to order too little or order too much. If you order too little, it means that your cost of transportation will increase because every time you go and order, they have to transport the goods. Why don't you maybe buy certain amount so that you can keep it for longer? Period. If you have too much to, it means that you have spent several amount of money to buy products or inventory or stock that you are not using immediately. That's what we call tying up of stock in inventory, right? So when you tie your stock or your money there, that would create some problems for you because the stock or your inventory is not able to take care of what we call sensitivity to capital. So assuming that every month you use a particular inventory, you use 10,000 cedis worth of that inventory. And you have gone to buy for 10 months, 100,000. Mean that you need to pay for products worth 100,000 for 10 months. Well, you are not going to pay for transport, bringing the product every month, thousand. But you may have to, maybe with your 100,000, one full truckload or half or two, three truckloads can bring it once and for all. Now, the idea here is that you are going to save on transportation costs, but again, your 100,000 is also locked up. Somebody who doesn't have 100,000 can still be buying 10,000, and still be able to achieve the same purpose. But this time, if you have to go for loan, you will pay loan on your 100,000 for 10 months. This person, if he has to pay interest on loan, the person will pay interest on only 10,000 at a time. So you see that that person's cost of financing the deal will be lower than you who will buy 100,000. But you also benefit from transport because that person, every month, the person has to pay for transport to get the items in. If they are in charge of transportation, if the supplier does not supply it for free. So you see that there are dynamics. So you need to balance both sides and see which one do I now, instead of buying for 3 months and for 10 months, can I buy for 3 months instead? Can I buy every quarter? Would that reduce my transport and also reduce my cost of keeping the items for that long? Remember, aside from tying up to your capital, if you buy for 10 months, if there are items you need to cool, you have to keep them in a cooler or cold environment, cold storage. Okay, security to ensure people don't steal the item. All those things are costs that are associated with the keeping of items for long. So in determining our EOQ, experts have come to agree that there's a formula. If you put it in and you give all the features of the product we are talking about, the inventory we are talking about, the stock or the item or material we're talking about, it's able to give you how much to order at a time. So that will reduce both your cost of storage, what we also call holding stock, and your other costs, cost of ordering the products. That will include carriage inwards and all those other uh, costs associated with the product. So how much to order and when to order? The when to order is the reorder level that we know, but the how much to order is the EOQ. So the concept basically is that you need to ensure that your two major costs, the holding cost and the ordering costs, are reduced to the barest minimum at the balance. That is why the EOQ concept is very important. So the assumption of the EOQ are that one, constant demand is guaranteed, or we assume that there will always be constant demand. even though this is not entirely 100% accurate, at least it gives some ideas that, yeah, we know, like even your own eating patterns are not the same. Some eat 3 times a day, some eat once a day, some eat 2 times, some eat 4 times. But those who even eat 3 times a day, some days they may end up eating only one, or some days maybe two, or some days 4 or 5. So it might change, but on the average, there should be some consistency. So in a week of 7 days, maybe about 5 days you are eating 3 times a day, the rest you are eating less or more. Then we know that that is a kind of a constant demand pattern we can be able to track. There should be constant lead time. The lead time is what time does it take? How long does it take when you order your products, and then when you receive it, or your inventory, or your stock, or your material item. Normally calculated in weeks, or you can calculate it in months or days. So if you have 3 weeks, for example, to receive item, then you should know that when you order the product today, you're not getting it today, you are getting it somewhere 3 weeks time from today. 27th of January could be middle of February. So if by middle of February your product will have depleted completely, it means the lead time must be shortened so that you can get your products in on time. Then we have single product system, because the the product may not be able to, or the formula may not be able to work with multiple products at the same time. So you have to develop EOQ for every product. You don't develop, you say EOQ for all materials in stock. No, you can develop for all of them, but each of them separately. So the EOQ for material A may be different from the EOQ for material B, right? And all will depend on the lead time, how long it takes. For example, if you order a car from let's say Germany, Mercedes-Benz, to be manufactured or to get stock, it may take longer than just ordering fruit juice from a nearby manufacturer, right? So the lead time will be different. So the same way the economic order quantities may be different. Even the kind of item, how long, how much are people buying, all those things would come in. And stock out. It assumes that there are no stock out. We don't have to have zero stock before you order. And then stable costs. It's believed that ordering and holding costs remain quite constant, even though in reality there might be some fluctuations, but yeah, we don't expect large variations. Otherwise, our formula might not serve you optimally. Yeah, but these are things that we need to assume before we can be able to work out something. So even though the EOQ system, due to this assumption, is not a perfect tool, it's quite good and excellent in helping you to decide on how much of product to order when your stocks are diminishing or depleting. So administrative costs like processing orders, cost of transporting, shipping, and all that will form part of the ordering cost, while the holding costs will be costs that you incur when the goods or the inventory or the stocks or materials have come to the organization, including warehousing, insurance, depreciation, obsolescence, the risk that the product may even expire. They are all part of that. So when goods expire, you throw them away. It's a cost. So all those things you have to be maintained. And then, so the total inventory cost, right? When we talk about total inventory cost, is cost of ordering plus the holding cost. Okay. So when you have a product in store, the total cost is not only how much you bought it from the supplier, but the cost of ordering. Sometimes before you even buy, you have to send people to go and examine the product to see the production environment, to see whether the supplies are heading to standard. All those things form part of your inventory costs. Okay, part of the ordering cost. That makes up the inventory cost. And you have to make sure that all these costs are reduced to the minimum level. And that's why the EOQ concept is very important. So this uh, a pictorial representation of what we can call an optimum stock. So you can see the total cost line, which is the red one, the holding cost line, the black one, and then the ordering cost line, the blue one. So you see total cost will be a combination of the holding cost and the ordering cost. While the holding cost is increasing, the ordering cost is reducing. And then the total cost is it's like a U shape. It reduces and then picks up. So it is high, reduces to the optimum, and then picks up again. So let me hear from maybe two people. One person, why do you think that the the holding cost keeps increasing throughout? Why does it increase throughout the process? And why does the ordering cost appear to be reducing, forming an intersection? Why is it so? Anyone? Anyone? Nobody? Okay. So with the holding cost, that has to do with the quantity of goods in store and how much you spend in keeping them. So if you have, let's say, 20 items to be kept in a fridge, if the fridge can take only 20 items, the moment you have 100 items, it means you need 5 different fridges or refrigerators for at the same time. So the cost of cooling, the cost of procuring refrigerators, okay, and security, insurance, risk of obsolescence, all those things make holding costs increase the more quantities you have. So the more uh, 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 inventory or materials you have in store, the higher the holding costs. But the ordering cost reduces because the more you order, the lesser the price, the cost, the price per unit. Why is this so? Because at the end of the day, if you are going to buy, let's say from Cape Coast to Accra, if you are going to buy maybe 100 items and you are going with your delivery or yeah, your van or your truck, um, you fuel it almost the same. So if your goods are even half truck load, you still buy almost the same amount of fuel. So if you are buying double or three times and they all can fit into the same truck, you pay the same uh, uh, cost of fuel, but you get multiple items in place. So the cost of bringing the things to the organization will now be lower. So there are several of these kind of reasonable reasons why the more you order or the more items you bring in, the ordering cost is reducing, but the holding cost is increasing. And it is where where they meet. That is the place you have your economic order quantity. So on your horizontal axis, you see the quantities that we're going to order, and then on the vertical axis, you see the annual cost. So this is the concept behind the economic order quantity. So the intersection between the ordering cost and the holding cost is where we have our economic order quantity. So the quantities could start from 0 up to maybe 100. And then with this diagram, you see it could be, let's say, around 30, 35 units. Okay, assuming it is from 0 to 100. All right, that is the amount of units you need to order to be able to keep your stock at a reasonable level. And that is what will give you the minimum or the minimal cost. At this point where the holding costs and the ordering costs lines or curves meet, they give you a level that if you order that quantity of goods, your holding costs and your ordering costs have met. So it gives you the lowest total cost. So if you look at the total cost line, that is the lowest dip. It was reducing, get to the lowest level, and then it peaks again. What this means is that if you order less, your total cost will increase. All right. You've seen the EOQ sign. If you move it back a bit, your total cost will increase. If you move it forward, your total cost will increase. If you order less, what will happen? If you order less, it will mean that your uh, holding cost will be less, but your ordering cost will be higher. If you order more, you see that the line will meet your holding costs at a lower level, but the ordering cost, the holding cost, if you order more, holding costs will increase, and then the ordering cost will reduce. So the best place is where the two of them have met, and that will give you the lowest cost. And that is how the EOQ is calculated. All right. So to determine the EOQ, the ordering costs and your carrying costs must be the major determinants. All right. And there are there's a formula that we can use in determining the EOQ. So, but the EOQ is made up of several components. But the annual holding costs, you have a formula to be able to determine the holding cost, because you need the holding cost and the ordering cost before you can be able to calculate the EOQ or the economic order quantity. So the holding cost is Q over 2 times H, where Q is your quantities that you order, and your H is your holding cost, also called the carrying cost per unit. The 2 is constant. So we're having some assignment to do some calculations on this. I'll send you an assignment. Your third assignment will be your EOQ, where you work in groups to discuss it, and then we can make some presentation in class maybe next week. So the total ordering cost is also calculated by looking at the annual demand over the order quantities or order size times the ordering cost per order. How much will it cost you anytime you place a particular order? Okay. So your total cost then is your holding cost plus your ordering cost, which is the formula Q over 2 times H plus D over Q times S. If you add these two, it gives you your total cost for keeping inventory. So we have the definitions here. We can go through later. So an example, if the annual demand for a product is 10,000 units, ordering cost is 50 cedis per order, and unit cost or the price is 4 cedis per unit. Interest rate at 25%. Find EOQ. And then 2, what is the total cost when you are ordering at EOQ level? So you see, let's go back to the formula. So you see the Q there is your EOQ. All right. And so can we be able to calculate this? Okay, let's look at this example together. So your demand is it 1,000 units? Yes, no, 10,000 units per year. All right. So okay, so I think I want you to discuss this so that tomorrow when we meet again, we can work on it, but try to capture this. You can do a screenshot of this particular example, and then you can discuss it in your groups. Now you have learning groups that we have formed out of this virtual classroom. Continue to work on some of these things by yourself so that tomorrow when we meet, we'll discuss it, right? So basically, all that is trying to tell you is to work out your EOQ and also your total costs. All right. So you have to look at this example here too. So you have to determine the optimal number of needles to order, where the demand or the D is 1,000 units. What is the S, which is 10 per order? What is that? What does S mean? What does the S mean? That is ordering cost. And then the H is what? Is holding cost. So the EOQ or Q, the economic order quantity, is 2DS over H, where the D is what? The annual demand. So, and then the S is cost per order. And then the H is who is trying to do something on this. Please stop writing on the page. Okay. On the screen, sorry. Okay. So remember the terminologies. One is D. The D is not monthly demand or weekly demand or daily demand. It is supposed to be annual demand. So in some questions, they will give you monthly demand automatically multiplied by 12. These are the ways that students are tricked in examination. The demand must always be what? Annual. So if they tell you monthly demand or weekly demand, you have to multiply and make sure you get it in a year form. Or if they say every 2 years they demand this much, then you have to divide it by what? 2 to get it for 1 year. So it's very important. All right. And holding cost, they can tell you the cost of holding the 1,000 units is maybe 5,000. You don't use the entire holding cost for all the items, but you use only the holding cost for one item per unit per year. So please, when questions like this come, take your time, because examiners will be trying to trick you. They will give you figures where you are not sure whether H is what is there, or you have to. So you need to, that's why I want you to work in groups, solve a couple of problems, and see the one that these figures are given in annual form, weekly form, daily form, and how to approach them. So the formula is the square root of 2DS over H. And when you work on this, you get 200 units as your economic order quantity. So it means that anytime you want to order new items for these needles, you need to make sure you order 200. And that one will reduce your cost to the barest minimum. You have the lowest level total cost. All right. So expected number of orders then will be, because our annual demand is how much? 1,000. And we are going to order 200 per every time that you order. So in a year, we order how many times? 5 times. This is also a very simple mathematics, right? If you need 1,000 cedis a year, okay, for your upkeep, and your parents say that they will be giving you 200 cedis anytime you need money, how many times will they give you money? They will give you 5 times to make 1,000 cedis. Basically, that's the point. Okay, the same thing here. So it means that you'll be ordering maybe every 2 months, kind of. So your order, or if your product is seasonal, then it may not be every 2 months. Sometimes it'll be, you order more during the season and you order less during the off-peak. But at every time, you have to order 200 units to be able to keep your holding costs and your ordering costs in check. So the expected time between orders will now be 50 days. Why is it so? Because you are looking at number of working days in a year over the number of times you order. You are going to order 5 times. So on the average, every 50 days, let's say every 2 months, as I mentioned earlier, on average, almost every 2 months, you'll be ordering product. You know, we have 365 days in a year, but this one uses the number of the working days, right? So every 50 working days, you should be ordering new products, basically. So you can fix it on your ordering calendar. That would be more than 50 days, about 50 working days. So you add the weekends to it, then it helps you in your calendar arrangement, or you just use the working days as stipulated. Yeah. So the total annual cost will be your holding cost plus your ordering cost. So the ordering cost is 2 over Q times S, and then your holding cost will be 2 over Q times H. That will give you your total cost per annum, which will be 100 cedis, right? If you do it well, all right? Then we can also do what we call sensitivity analysis. What is sensitivity analysis? People call it what if analysis. So assuming we order 500, what will be our holding cost? What will be our ordering cost, and what will be the total cost? Assuming we order 1,000 units, what will be the effect on cost? Assuming we order 1,005 instead of the 200. Remember, we mentioned that it's supposed to be 200. So you can even do 100. Assuming you order 100, what will be the effect? You can do that in your groups. So you can screenshot this also, do it in your groups, and then you can see the effect. You see that for each of the things that are less or more than the 200, you see something reflecting in cost. Okay, so do it also as an assignment for me to look at next week. So there's another example here. You can have that's for a company that makes bicycles. Okay, it produces 450 bicycles a month. That's the production. It buys the tires for bicycles from a supplier at a cost of 20 per tire. The company's inventory carrying cost is estimated to be 15% of cost, and the ordering is 50 per order. Calculate annual demand, calculate EOQ, calculate total cost. What have you seen here? What is one of the things that looks a bit tricky here for you to work on before you even start work? Hello, can you hear me?
Yes, please, we can hear.
Yes. Have you seen anything tricky about this question, for example, that you think you need to work on before you even start solving the question?
Yes, please. You said
Okay.
Yeah.
producing 450 bicycles and a tie. So meaning 2 ties to a bicycle. So you have to multiply 2 by the 450.
Yeah.
Okay, that is one. Good. So bicycles use 2 tires. So yes. So for every bicycle, you have 2 tires. All right. So that is one. So for the 450 bicycles per month, it means that will automatically require you to buy 900 tires for the
Yes,
450
please.
bicycle. Is that the case?
Yes,
Yes,
please.
please.
Okay. What else? So you've also seen that I explained a bit earlier today that the demand should be annual. But I see that they have given you this one in months. So automatically, you have to calculate how much or how many tires they will demand for the whole year for production to take place. That then will mean your 900 by what?
By the months in the year.
Yes,
So
that is times what? 12, right?
Yes, please.
So that automatically gives you a figure that is in the several thousands, more than 10,000. I think 10,800 or so, or something like that.
Yeah, 10,800.
Good. So that becomes your annual demand, so your D. So these are the things you need to look out for whenever you will try and organize some tutorials, but these are just a few, how will I call it, heads up whenever you are solving this question. But please meet as a group, solve this question, solve it on your own. Even you can use AI to explain why things are like this. It can give you some more explanation and it will be very good. questions like this, normally you'll find a question like this definitely in examination for inventory management course. You'll find something on EOQ calculation and total cost and all that. So there's another question. Yeah, I'll leave it for you and what you're supposed to do. All right. So I'll send you these notes. Don't you have, I think you have all the notes, right?
Sir,
No,
please, what note?
You don't
No,
have the notes?
please. No, please, we don't have.
No, please.
Okay,
No,
then
and not all the lecture slides too.
okay, so I'll try and send you all the notes so that you can have it and maybe also read ahead. So all the notes we've all the lecture notes we've covered so far, you have them. All right, so these are examples that I want you to go through, solve the problems so that you get a more in-depth understanding so that when we meet, we'll discuss next week. But tomorrow we'll meet face-to-face for a class. So the reorder level, okay, or reorder point is at what point would you order a new product? I think we have discussed this already. So at the reorder level, the quantity you order is what we call the EOQ. That is the amount of goods or inventory you want to order. So that's another illustration of determining the reorder level or the reorder point. That is your maximum lead time times maximum usage. The lead time is how long it takes for the product to be delivered, and the maximum usage is looking at how much you would use or how much of the products you use. All right, maybe for production, maximum usage can also be maximum sales. All right, that one doesn't have to be annual. It will be giving you any unit. If it's a week or whatever, you have to use that one and calculate it in that particular unit. All right. It means that stocks are replenished, maybe, or stocks are going out on daily basis or weekly basis. They do those calculations. So this is also another example here you can solve or you work together in groups. Then we have safety stock. That's the stock level that would help give a kind of a buffer, okay, against stock outs. So you have to make sure you guard against stock outs by keeping a safety stock. Sometimes some of us keep money in our safe, right? Or somewhere, money box we call it, so that in case we are hard pressed, we can go in for it, right? So we don't keep all our money in our pockets. Otherwise, you will spend everything. So some of you do Momo Save, okay? Yellow Save or whatever, the other one. Yeah, I also do that so that when I'm in financial hardship, I can quickly fall on those savings. And that is what we call the safety stock. So whenever you have stock, you go and keep some somewhere in case of emergency, you can use those ones. So you can also calculate the safety stock level to be reorder level minus minimum stock level, or you can use average stock, average usage time, average lead time. Both of them give you almost the same answer for safety stock. So that does it for today. Thank you. Any questions?